Hi, here we have a group of workers was put on a job. From the second day onwards, one worker was withdrawn every day. The job was finished when the last worker was withdrawn. Now, had no worker been withdrawn at any stage, the group would have finished the job in 2/3 the time. How many workers were there in the group? Okay, so let's say in the first case, when a worker is being withdrawn every day, the work gets completed in n days. So we have day 1, day 2, day 3, so on till dn. And if the work gets completed in n days, there must have been n workers because, well, okay, let's do one thing. Let's start with the other assumption. Let's say the total workers initially is n, right? So on day 1 there are n people working, number of workers working. So on day 1 there will be n people working. On day 2 one of them will leave, so there will be n minus 1 people working on day 2. On day 3 there will be n minus 2 people working, and so on till there is only one person left. And when will this one person be left? It will be on the nth day, right? So you see, this number of the day and the number of workers, the sum is n plus 1, n minus 1 and 2 is n plus 1, n minus 2 plus 3 is n plus 1. So if there is only one worker remaining, it will be on the nth day, n plus 1. Okay, and once n days are completed, this person will also leave, and that's it. Then there will be no one left to work and the job will be finished. Once this person leaves, as soon as this person leaves, the job is finished. Okay. Now assuming that efficiency per worker per day is 1 unit. So every worker completes 1 unit of the work every day. So in this case, work done per day. What is the work done per day? Let's calculate that. There are n people working on day 1 and efficiency of each person is 1 unit. So the amount of work done will be n into 1. Similarly, on second day there are n minus 1 workers working and efficiency of each worker is 1 unit per day. So amount of work done will be n minus 1 into 1. Similarly, you'll have n minus 2 into 1 on the third day, so on till 1 into 1 on the last day. Okay, and now the total work done will basically be the sum of work done on each of these days. So work done on first day is n units, on second day is n minus 1 units, on third day is n minus 2 units, so on till on the last day it will be 1 unit, on the second last day it would have been 2 units, on the third last day it would have been 3 units, and so on. So this is the total work done. Now what is this? This is simply sum of first n natural numbers, right? So sum of first n natural numbers is n into n plus 1 by 2. This is the total work that would have been done in n days if work is completed in this fashion. Now it's also given that if no worker withdrew at any stage, the whole group, that means n people would have finished the job in 2/3 the time. So if n people at an efficiency of 1 unit per day would have finished the work in 2/3 of the time, so initially the time taken was n days, now the time taken will be 2/3 of n. That means the total work they would have finished is, number of people is n into 1. This is work done by n people in 1 day into number of days. So this is the total work done by n people in 2/3 of n days. Now it's pretty simple. The work done in the first case and the work done in the second case should be same. It's the same work that we are talking about, isn't it? So what we need to now do is equate the two work dones. N into n plus 1 by 2 is equal to n into 1 into 2n by 3. So we have n cancels out. This 3 gets multiplied here, thrice of n plus 1, and this 2 gets multiplied here, twice of 2 is 4n into 1. So we have 3n plus 3 is equal to 4n. 4n minus 3n is n, which is equal to 3. So the value of n comes out to be 3 over here. Now the question was, how many workers were there in the group? So the number of workers was n, and n is equal to 3. So the answer here is option B, 3. Thank you.